Didn't know I'd be so outnumbered and be thrown under the bus a couple times here. So that is true. We love the landscape architects. So I'm Merril Taylor. I come from Tetra Tech, San Diego. We've done a bunch of work with the county and the city. Some of the stuff that's been shown, we've had our fingerprints in, and we're here. I'm here today to kind of talk about one of the green streets that has actually been implemented by the city of San Diego. That's over at Bannock Avenue. Go ahead. All right, so some of the goals of this project, obviously, as Stephanie talked about, we have MS4 compliance. So the city of San Diego is required to improve their water quality through different projects, both structural and non-structural. And so the city wanted to sort of put this as one of the first structural projects out there, or for one of the first large-scale Green Street structural projects out there to sort of, comply with their MS4 permit. Also to reduce the pollutants. This area is right above Tecolote Canyon, so it drains right into Tecolote Creek and eventually out to Mission Bay. And Mission Bay and Tecolote Creek are listed for bacteria. They have 303D listings and TMDLs for bacteria. They also have 303D listings for heavy metals, nutrients, toxicity, turbidity, all those sort of items that can cause problems downstream. As I said, the city also wanted to use this as a pilot project. Not a lot of large-scale Green Street projects have gone in within the city of San Diego, and so they wanted to gather information about how these things work to sort of create standard practices. And we're currently working with the city to sort of standardize some of the items that are part of these green streets, whether they're the details for under drains or details for permeable pavements. Details for bioretention cross sections, those sort of things. So the city wanted to use this as one of the first sort of areas to try to test and look at these things and learn what sort of things work and what don't and what can be improved on. And we've definitely taken a lot of knowledge from this to further the city down the road. As Stephanie mentioned, the WQIPs are also here, the water quality improvement plans. And those plans specify green streets as one of the options, and it relies heavily on green streets to reach these waste lead allocations that these cities are required to meet. And so the city wanted to make sure that they had a good understanding of what would work for green streets and what would not. And then finally, the streetscape enhancement. They want the neighborhood to look nice. All right, so the project area. So this is located up near Claremont Mesa and Genesee. So it's in the Claremont community of San Diego. And this is sort of the project outline. So you can see here, we sort of cover a number of different streets. We have Claremont Mesa, we have Manitou, which is here, and Bannock Avenue. And so the city elected a number of years ago, this was identified as a conceptual level project. And they approached us to actually take it to full design. And initially the watershed went all the way up into here, up into this neighborhood, but they cut it back because it was getting quite expensive for them to try to implement green streets on a 60-acre watershed, and so they cut it down to 20 acres. And so you can see it's pretty residential, a lot of single-family homes up in this area. You do have some multifamily homes down in here, a couple little commercial type items. So just kind of a pretty standard little neighborhood. Go ahead, next slide. All right, so I wanted to kind of touch on, and I have a couple of animations here, so I'll have you click here. So this again is the plan set. And so what we did is we first went out, and I just want to briefly touch about how the design went in. I'm kind of going to focus more on the construction and the plans going forward. But what we did is we went out and we checked out to see what sort of parkways were in this area. And so we had different classifications. We had easy, which means they just had a grass or a turf, something really easy that could be torn out. Possible, they might have had some shrubs, small trees, those things that haven't been well established. We had difficult hardscape. The resident has come out, put brick, some other sort of concrete. Or we had difficult because of large mature trees. So we went out, took a survey of all of that area. So you saw the plan set behind it. We looked at all of the parkways within there and classified each parkway in front of each house with one of these four categories. So go ahead and go to next. So what we then did was with each of these classifications, we were able to assign a price. So we said in an easy application, that price is going to be 72 cents per square foot. For medium, or for the possible ones, those were going to be $336 per square foot, and ones with trees were going to be like $500 a square foot. And so we assigned these different price values to these different parkways. And when in doing that, we then took all the drainage area to each of the little parkways in front of each house and ran it through an optimization model. This is the EPA sustain model that EPA has put out, and it allows you to weigh and vary the effectiveness of the cost versus the pollutant reduction. And so in what we were looking at was trying to target bacteria reduction because of the bacteria TMDL. And so we wanted to try to figure out where to best put these things at the cheapest cost and get the same amount of reduction. And so what Stephanie talked about earlier is the 85th percentile storm is a requirement for a lot of the new development that's going in, and a lot of redevelopment. This project was not adding any pavement. It was not going in and putting new driveways or things like that. And so there was no real regulatory driver on what size they had to put in there. The 85th percentile is a very common size. It's something we see all the time. And so what we wanted to do was to see how big we had to make it to capture the 85th percentile storm. So you see over here this yellow dot. This yellow dot showed us that this is how big you had to make it to capture your 85th percentile storm. So somewhere up in the $3.7 million range. And so we plotted this curve out and said, okay, let's look at all sorts of combinations. And because we don't have the requirement to capture the 85th, what if we come back and measure and find the same effectiveness? So at 85th percentile size, we had about a 78% reduction in pollutant. And we can make something a lot smaller that removes the same amount of pollutant for a half or just under half of the cost. And so in doing this, we've then targeted, and you can see it's the 71st percentile storm, which is about 0.35 inches, 0.35 inch event. And so we were able to get the same pollutant reduction for a much cheaper cost to save the city quite a bit amount of money. Go ahead, next slide. All right, so as we talk about, I know they're not nice round systems or nice engineered trapezoids here, but we did two different designs. So we did just typical bioretention in a standalone. So the bioretention would act alone in certain areas where we could capture and get enough of that 71st percentile storm to provide that treatment. So we had these standalones. We had ones that fit in the existing parkway, and on one side of the street was actually pretty wide. And so we were actually able to push into the street to narrow the street to cause a little bit of traffic calming, and also to get a little bit more storage space for these bioretention cells. Go ahead, next slide. And so in some areas we had to capture a lot more water, and to do that we built these bioretentions in conjunction with permeable pavement. We did use pervious concrete in this application to get that extra bit of storage. And so we created this sort of dual system where with bioretention and permeable pavement acting in conjunction one with another. Go ahead, next slide. All right. So this is where we wanted to try to reach out to the neighborhood to get their feedback and get some ideas on what they would like to see. So the city of San Diego made it a priority to mail out a mailer to all of the residents and all of the owners within that neighborhood to get an idea to get a little bit of ownership of what goes within their front yard or within their parkway in front of their front yard. And so we provided each of the residents an option of one of the following, one of the two trees. They could do the desert willow or the western redbud. The shrubs, they had the yarrow or the fuchsia, and then ornamental grasses with the gray rush or the deer grass. And so we had our landscape architect. We worked with Garbini and Garbini on this project. They're the ones who identified the plant palette as the potential plants. They also put together some renderings for us to show sort of what these things could look like so the neighbors can visualize it and see what it might look like down the road and in the future. And we actually received back about just over 50% of the neighbors actually sent something back asking for certain plants and certain trees. And we took that information, incorporated it into the plans to make sure that we put the trees and the plants that they wanted to see. Go ahead, next slide. All right, so I'm not going to go too deep into the details of construction. It's a construction project. We have lots of different issues. Overall, it was a pretty successful, pretty good project. There were some issues. Go ahead and keep clicking through. We got a couple of funny issues. That's our energy dissipator that's supposed to slow the water down as it comes into the cell. Clearly, that's not slowing anything down. We actually had a lot of huge cobbles that were not identified. We did do geotech borings. We did about 10 of them before the project, and they did hit a lot of resistance, but the boulders that they hit were a lot bigger than they were expecting to hit. You got this pervious pavement. Clearly, they should not be putting their material on top of that. So we had some interesting construction type issues while we were out there. They eventually understood that, we literally told them, have you ever seen the game show, The Price is Right? And if you watch Plinko, we need this thing to act like a Plinko type system. And that actually got through to them, and they finally figured out what this thing was supposed to do. So there were some issues teaching the contractors, teaching them to make sure that, you can't put your material on top of the pervious pavement that you just installed, because you're going to clog your pervious pavement. Your liner, this area had very expansive clay, and so we had to line the system, although I wish we didn't have to. We had to line it because it had very expansive clays underneath here, and so we wanted to make sure that we did not expand to cause cracking or other issues underneath some of these sidewalks and houses. So we had to teach the contractor. The contractor was pretty open to hearing a lot of these things, and we tried to get them to understand that this is not just your typical roadway construction project. Go ahead, next slide. All right, so after many months and lots of pulling teeth with the contractor and things, this is what the project ended up looking like. So we had these good splash pads. This is one of those areas that popped that curb out. And it was pointed out on Elmer Avenue. We actually took from Elmer Avenue that idea of having this sort of pedestrian pad so that you can hop out of your car and have a good 18-inch pad to be able to step on. These are curb cuts with a grate over the top of them, be able to give that sort of allow the flow to go in, not have the same clogging type issues they had at Elmer, and be able to also have a continuous surface to be able to walk on. So these are some of the final what they look like after the plantings and everything was put in. You can see we have that mulch in there. As was pointed out, the mulch is quite important, and it plays a very large integral role in the performance of these things. Next slide. Another couple slides just showing sort of the little bit of the features. So you can see those rocks there to be able to slow down that flow to prevent erosion. We also have check dams on one side of the road. It was quite steep, so we had to install these little check dams to allow the flow to slow down so it wouldn't erode out our items. Next slide. All right, so what do we want to do? As I mentioned, the city wants to learn a lot about this project. So they want to see how the overall load reductions that they can get on a green street. As was mentioned, the bioretention soil media, they're also monitoring 3 different kinds of soil media at this site. And I'll talk a little bit about that in the next slide. I got a couple minutes. They also want to validate and update any modeling parameters. So a lot of the modeling parameters we've been using are from studies up in Washington or back east in North Carolina. And so we want to make sure that the assumptions of reductions and things like that we're using are actually valid for this region. And then also comparing our climate region to others to see if some of those parameters make a difference or not. Go ahead and go to the next slide. So what's going to be monitored? They're going to look at the influent flow, the underdrain effluent flow for each of the 3 media mixes. These are some of the parameters they're going to be looking at. This monitoring plan is actually going into effect this next fiscal year, so it's starting in August. They're going to actually be out there putting all this equipment in there to actually monitor and see how this thing is performing. It has been in for about a year. It's not 100% complete. There's a couple of last-minute construction things that need to get done, but once it's completed, then they'll be able to monitor. So it's been out there for about a year, gone through the first wet season, and now it's going to be monitored starting the next year. Go ahead. All right. So where are they going to monitor? So they're going to monitor up on Claremont Mesa. They're going to monitor it on Manitou, and then they're going to monitor at the outfall down here, which goes right into Tecolote Canyon. And then, as I mentioned, they have 3 different soil mixes. So in all these 3 areas, they have a bioretention soil media A. And without going into too much detail, this is the 70% sand, 30%. This was before the county one was put together. This was put together back in 2011 or 2010. Since then, there has been updates, as was mentioned, with the county. We also, as Jim mentioned, we were part of helping put that together. We have a media B, which has a little bit higher organic content than the media A. to be able to see the effect of that organic content. And bioretention soil media C actually has a special zeolite compound which is integrated into it to see what sort of impact that has on removing metals and those sort of items. Next slide. All right, so how they're going to monitor it. They're going to monitor at the inlets and outlets, as I mentioned. They've got some pressure transducers, outlet monitoring, ISCO samplers, and those sort of items. I'm not going to go too much into detail on that. Next slide. So this is it performing after its one of its rain events here. As you can see, they have that temporary construction fencing. Like I said, they're not quite 100% done with it. But this was during one of the more recent rain events. And so you can see the water is going in there and pretty much disappearing pretty quickly. This was quite after the storm event. And on that bottom slide, I just wanted to kind of point out, you can see the kind of flows that they were getting to this catch basin before. So on this side, there is no LID. This goes up around to Genesee. And so there are no items on there. So they're getting quite a bit of flow. But on this other side, where these green streets have gone in, they're getting zero flow coming to this catch basin. So it's performing very well. It's, like I said, it's made it through its first wet season. We're going to see how it does over the summer with its first dry season. These systems are not irrigated. The city of San Diego actually flat out said that we are not installing irrigation within this system. So the contractor was on the hook for the first year to go out there, water it to make sure the plants were all established and good to go. And the contractor got fired, so they've not been taken care of They've not been taken care of since about August, and so, but they're still looking pretty good. So this was not too long ago. Some of the trees are a little bit crispy, but the plants and grasses are actually looking pretty good. And Marty will tell you we've had lots of discussion about trees and these things. So, anyways, but that's it. So,
can I just ask one
yeah,
question?
real quick.
I realized that the contractor was on the hook to maintain the plants for the first year. Does the city anticipate having an agreement with the residents in the future to maintain any of that, or are they considering the parkway really part of their right-of-way and not entering into agreements?
I don't know the exact answer to that. I know that in the last talks we had with them, the plan or the idea that they had was that the contractor would be on the hook for the first year of watering it, maintaining it, and making sure that the plants were established and removing any dead plants and those sort of things. Beyond that, I know that the city, for the meantime, is planning on maintaining. So the city is going to go out and maintain this thing. They're gonna go out, weed it, pull the trash, all that sort of stuff. I'm not aware of any program or anything they have at the moment because obviously if these go large scale, they're not going to be able to do every single one of them. So there might be something in the works, but I'm just not aware of it.
Okay.
So.
Why was there no irrigation allowed on that? Was it a budget thing, or was it?
The city elected to not irrigate it, and the city has basically said that these are stormwater features that are meant to treat stormwater. Why are we going to put potable water inside of our storm feature? Is the shortest explanation. And so, again, this was a pilot project, so there is going to be an opportunity for learning to see if the no irrigation is going to work or not. And so we'll see how it goes. And like I said, this summer is going to be the first sort of dry season that this thing is going to be going through. The construction on it finished back in August, August was about when the last time they watered it, and so everything since then has been either over irrigation from lawns, or nuisance flows, or the rain events that we've had, or the lack of rain events that we've had. So we'll see how it goes through this first summer. But thank you.